Today we are going to discuss the Unit 5 from BSc 3rd year syllabus, Solutions, Dilute Solutions and Colligative Properties. In this episode, we will discuss what is solution, types of solutions, solubility and various concentration terms. Now, what is solution? A solution is a homogeneous mixture that consists of one or more solutes uniformly dispersed at the molecular or ionic level throughout a medium known as solvent. Homogeneous mixture means it is not possible to see boundaries between the components. Solvent is the substance which is present in larger amount, and the solute is the substance which is present in smaller amount than the solvent. There are 7 types of solutions based on the state of solvent and state of solute. For example, if state of solvent is gas and state of solute is also gas, the solution will be gaseous, and we can take air as an example. Similarly, there can be 7 types of solutions which you can see in this table. The solution of liquid in gas or solid in gas is not possible because the constituents cannot form a homogeneous mixture. Now, what is unsaturated solution? If less than the maximum amount of solute for that temperature is dissolved in the solvent, the solution is known as unsaturated solution. In unsaturated solution, no solid remains behind in the flask. Now, what is saturated solution? When solvent holds as much solute as is possible at that temperature, the solution is known as saturated solution. Undissolved solid remains in the flask in case of saturated solution. Dissolved solid is in dynamic equilibrium with solid solute particles. There is another kind of solution known as supersaturated solution. The solution that contains more solute than allowed by the solubility, or a solution formed when more solute is dissolved than in a saturated solution. The solution will be known as supersaturated solution. Supersaturated solution is not a stable system, since there is more solute dissolved than the solvent can accommodate, and the excess solute will come out of the solution and will crystallize as a solid, or it will separate as a liquid, or it will bubble out as a gas. For example, soda. Crystallization can often be stimulated by adding a seed crystal or scratching the sides of the flask. You can see the degree of saturation in 3 flasks. First one is unsaturated solution, the second one is saturated solution, and the third one is supersaturated solution. Supersaturated solution contains more solute that can be dissolved at the current temperature. Now, how will you make a supersaturated solution? First, heat the solvent, saturate it with solute, and then cool slowly. Sometimes the excess will precipitate out. If it does not precipitate, the solution will be supersaturated one. Now, solubility and the solution process. The solid dissolves rapidly at first, but as the solution approaches saturation, the net rate of dissolution decreases, since the process is in dynamic equilibrium. When the solution has reached equilibrium, the amount of solute does not change with time. At equilibrium, the rate of dissolution is equal to the rate of solution. Now we will discuss some concentration terms. What is dilute solution? The solution which does not contain a lot of solute is called dilute solution, and the concentrated solution is the one when a large amount of solute is present in the solution. Concentration can be expressed quantitatively in many ways: percentage composition, molality, molarity, mole fraction, normality, formality, and ppm, that is parts per million. What is mass percent or percent by mass? It is defined as the amount of solute in grams present in 100 grams of solution. Mass percent will be equal to mass of solute upon mass of solution multiplied by 100, or you can say that mass of solute upon mass of solute plus mass of solvent, that is mass of solution multiplied by 100. Percent by volume. It is defined as the volume of solute in ml present in 100 ml of solution. Percent of solute by volume is equal to volume of solute upon volume of solution multiplied by 100. Now, what is percent mass by volume? It is defined as the mass of solute in grams present in 100 ml of solution. Percent of solute mass by volume is equal to mass of solute upon volume of solution multiplied by 100. Now, let us take an example for calculating weight by volume percent. Calculate the percent composition or percent weight by volume of 2 into 10 to the power 2 ml solution containing 20 grams sodium chloride. Now, mass of solute is 20 grams, total volume of solution is 2 into 10 to the power 2 ml, hence percent composition weight by volume will be equal to 20 upon 2 into 10 to the power 2 into 100, that is 10% weight by volume of sodium chloride. Now, let us discuss the strength or concentration in grams per liter. It is defined as the amount of solute in grams present in 1 liter of solution. Concentration or strength of solution is equal to mass of solute in grams upon volume of solution in liters, or mass of solute in grams upon volume of solution in milliliters multiplied by 1000. Let W grams of the solute is present in V liter of the solution. Then strength or concentration of the solution is equal to W upon V grams per liter. V is not the volume of the solvent, but it is the volume of the solution. Now, what is parts per million, that is ppm? When the solute is present in trace quantities, it is convenient to express the concentration in parts per million. It is defined as the quantity of the solute in grams present in 10 to the power 6 grams of solution. ppm is equal to mass of solute upon mass of solution multiplied by 10 to the power 6. ppm can be defined by mass and mass by volume and also by volume by volume. Let us define mole fraction. It is defined as the ratio of number of moles of one component to the total number of moles of the solution that is all the components. If Na moles of solute A and Nb moles of solvent B are present in the solution, mole fraction of solute will be equal to Na upon Na plus Nb, which can be denoted by Xa or Xi A. Mole fraction of solvent will be equal to Nb upon Na plus Nb, which will be equal to Xb or Xi B. Hence, Xa plus Xb will be equal to 1, means mole fraction of A plus mole fraction of B will be equal to 1. Mole fraction is independent of temperature. There is another term related to concentration, molality. It is defined as the number of moles of the solute present in 1 kg of solvent. It is denoted by small m. Molality is equal to number of moles of solute upon number of kilograms of solvent. If Wa grams of the solute of molecular mass Ma is present in Wb grams of the solvent, then molality will be equal to Wa upon Ma into Wb whole multiplied by 1000. Now, let us take a practice problem. A solution contains 0.0653 grams of a molecular compound in 8.31 grams of ethanol. The molality of the solution is 0.0368 molal. Calculate the molecular weight of the compound. Now, use the equation molality is equal to moles of solute upon kg of solvent. Molality of the solution is 0.0368, which will be equal to moles of solute, that is 0.0653 upon molecular mass divided by kg of solvent, which is equal to 8.31 divided by 1000. Putting all the values, you will get molecular mass equal to 213 grams per mole. Let us have a look on another practice problem. Fructose, which has a molecular formula C6H12O6. How much water should be added to 1.75 grams of fructose to give a 0.125 molal solution? Putting all the values in the equation, molality is equal to moles of solute upon kg of solvent, you will get the value 77.7 grams of water. There is another practice problem for you. Caffeine with molecular formula C8H10N4O2. A sample of the substance was dissolved in 45 grams of chloroform CHCl3 to give a 0.0946 molal solution. How many grams of caffeine were in the sample? Again, use the same formula. Molality is equal to moles of caffeine upon kg of chloroform, or moles of caffeine is equal to molality multiplied by kg of chloroform. Putting all the values, you will get the mass of caffeine equal to 0.826 grams. let us relate mole fraction and molality. Mole fraction of solute is equal to Na upon Na plus Nb, and mole fraction of solvent is equal to Nb upon Na plus Nb. Now, mole fraction of solute upon mole fraction of solvent will be equal to number of moles of solute upon number of moles of solvent, which is equal to Wa by Ma upon Wb by Mb. Now, by equating, you can see that Xa, that is mole fraction of solute multiplied by 1000 whole divided by mole fraction of solvent into molecular mass of solvent will be equal to weight of solute into 1000 upon weight of solvent into molecular mass of solute will be equal to molality. There is another term related to concentration, molarity. Now, let us discuss molarity. Molarity is defined as the number of moles of the solute present in 1 liter of the solution. Molarity is denoted by capital M. Number of moles of solute upon number of liters of solution or number of decimeter cubes of solution. If Wa grams of solute of molecular mass Ma is dissolved in V liter of solution, then the molarity of the solution will be equal to Wa upon Ma into V, or molarity into Ma is equal to Wa upon V will be equal to strength of the solution, which is denoted in grams per liter. If V is taken in milliliters or centimeter cube, then molarity of the solution will be equal to Wa upon Ma into V whole multiplied by 1000, means you have to change the milliliters to liters. The unit of molarity is moles per liter or moles per decimeter cube. Let us take an example for calculating the molarity from moles. Calculate the molarity of 2 liters of solution containing 5 moles of sodium hydroxide. We can use the equation molarity is equal to moles of solute upon liters of solution. Substitute all the values to this equation and you will get the molarity is equal to 2.5 molar. If you are given mass of the solute, then also you can calculate the molarity. If 5 grams glucose are dissolved in 1 into 10 to the power 2 milliliters of solution, calculate molarity of the glucose solution. Molar mass of glucose, as you know, is 180 grams per mole. Now, number of moles of glucose will be equal to 5 upon 180, and this will be equal to 2.78 into 10 to the power minus 2. Now, 1 into 10 to the power 2 ml will be equal to 1 into 10 to the power minus 1 liters. Molarity of glucose will come out to be 2.78 into 10 to the power minus 1 molar. Let us have a look on dilution. Dilution means adding more of solvent. Dilution is required to prepare a less concentrated solution from a more concentrated one. In dilution process, will the number of moles of solute change? Definitely no. So, number of moles of solute before dilution will be equal to number of moles of solute after dilution. Hence, we can use the equation M1V1 equal to M2V2. Here, M1V1 is the number of moles of solute before dilution and M2V2 are the number of moles of solute after dilution. Actually, moles of solute is equal to molarity of the solution into liters of the solution. Knowing any three terms permits calculation of the fourth one. If we mix two or more solutions, we can calculate the molarity of the resulting solution. Let there be three samples of solution containing same solvent and solute with their molarity M1, M2, M3 and volumes V1, V2 and V3 respectively. These solutions are mixed. Molarity of the mixed solution can be given as M1V1 plus M2V2 plus M3V3 equal to molarity of mixture multiplied by total volume of the solution after mixing, that is V1 plus V2 plus V3. Now, calculate the molarity after dilution by the help of this example. Calculate the molarity of a solution made by diluting 0.05 liters of 0.1 molar HCl solution to a volume of 5 liters. Here M1 is the molarity of the solution before dilution, which is equal to 0.1 molar. M2 is the molarity of the solution after dilution, which has to be calculated and we have taken it x molar. V1 is the volume of solution before dilution, which is equal to 0.05 liters. V2 is the volume of solution after dilution, which is equal to 5 liters. Put all these values in the equation M1V1 equal to M2V2 and you will get the molarity of the solution after dilution, which is equal to 0.001 molar or 1 into 10 to the power 3 molar HCl. Now, let us compare molarity and molality. Molarity and molality are never equal, but the difference becomes smaller as the solution becomes more dilute because the denominators are very similar. Molarity is more useful when dealing with solution stoichiometry, but molality is more appropriate for dealing with physical chemistry because molality does not change with temperature. Conversion between two requires the solution's density. Let us deduce a relationship between molarity and molality. Molarity upon molality will be equal to mass of solvent in kg upon volume of solution in liters. This will be equal to mass of solvent in grams upon volume of solution in milliliters, which will further be equal to Wb upon V. Here Wb is the mass of solvent and V is the volume of solution. Let the density of the solution is D grams per ml. Now, mass of solution will be equal to V into D, that is volume into density. Mass of solute will be equal to number of moles multiplied by molecular mass of solute equal to Na. Na is the number of moles of solute and Ma is the molecular mass of the solute. Mass of solvent Wa will be equal to mass of solution minus mass of solute. This will further be equal to V into D, which is equal to mass of solution minus Na into Ma, which is equal to mass of solute. Hence, molarity upon molality, that is capital M upon small m, is equal to V into D minus Na into Ma whole divided by V, that is volume of solution. Let us discuss another concentration term, normality. It is defined as the number of gram equivalents of the solute present per liter of the solution. It is denoted by capital N. Now, normality is equal to number of gram equivalents of solute upon number of liters of the solution. If Wa grams of the solute of equivalent mass Ea be present in V liters of the solution, then normality is equal to Wa upon Ea into V. Here Wa is the weight of solute, Ea is the equivalent weight of solute and V is the volume of solution. Now, normality is equal to Wa upon Ea into V, and normality into equivalent mass will be equal to Wa upon V. Recall that Wa upon V is equal to strength of the solution in grams per liter. Another term related to concentration is formality. Formality is the number of formula mass in grams present per liter of solution. In case formula mass is equal to molecular mass, formality is equal to molarity. Like molarity and normality, the formality is also dependent on temperature. It is used for ionic compounds in which there is no existence of molecule. Mole of ionic compounds is called formole and molarity as formality. In today's episode, we have defined solution, solute, solvent, three types of solutions, that is saturated solution, supersaturated solution, unsaturated solution, various concentration terms, mole fraction, percent composition, percent mass by mass, percent mass by volume, percent volume by volume, molality, molarity, ppm, normality and formality. You can also practice some more exercise to get hold on the topic. Thank you.